Hi, welcome to another episode of Submersed in Science. I'm your host, Jamie Steele. Today's episode will be from the Huntsman Marine Science Center. We're going to talk to folks here about the aquaculture research that goes on. Earlier, I had the pleasure of talking with Program Manager Chris Bridger and research scientist Amber Garber. Here are those interviews. Can you tell us a little bit about the early history of the aquaculture program here at Huntsman?
So some of the first projects that the Huntsman was involved with from an aquaculture point of view actually also included the Atlantic Salmon Federation. Okay. There was, back in those days, there was a large part of the effort was into finding a stock of fish from the river systems in the Bay of Fundy that would be appropriate for the aquaculture industry. And so the Huntsman with Brian Glee played a pretty pivotal role in that and determining which stocks, because some stocks, strains of fish don't do as well performance-wise in sea cages. Right. And so that was the very early days is where the effort was actually placed.
Right. Huntsman is also known as not only a research institution but also an educational institution. Was there any early involvement in education vis-a-vis aquaculture?
Yeah, absolutely. So very early on there was in fact a sea cage site just off of us here in the water, and there was some trial there that was going for various technologies, but in addition to that was the precursor for the aquaculture technician program. So the early days, this is even before the New Brunswick Community College started their program actually at NBC St. Andrews, where it's actually housed today. The program was initially done by Huntsman into sort of an outreach role for the actual industry, as it, of course, there was no technical skills here in the beginning because it was the very beginning. And so it had a lot of education both in the freshwater side of things, right, for the hatcheries, but also into the sea cage side, keeping workers safe and efficient as the industry grew.
Right. So the aquaculture technician training program began here more or less.
Began here more or less.
Right, and it's been going for what? That's 30 or more years.
That's right, yeah.
So hundreds and hundreds of students have come through that program, and you probably, you know, if you were to try to link all of those people involved in the aquaculture industry here in New Brunswick, they would probably all have a link back here to Huntsman.
Yeah, it's actually amazing to even walk around town in St. Andrews and talk to people that have an association at some point in their lives with Huntsman and or DFO SABs.
Right.
You know, everything down here on this one point, and it's affected a lot of roles of people.
And that probably extends beyond this community, but to Charlotte County, to New Brunswick, to Nova Scotia, to right across the country. I mean, you're from Newfoundland.
I'm from Newfoundland.
Yay.
Yay.
And you're here in New Brunswick. That's right. Great. So over the years, I mean, this program goes back to 30, 40 years ago. You must have seen some incredible changes in the facility here. I mean, I can remember when I worked here, you know, this building that we're sitting in wasn't here, for example. Can you tell us a little bit about some of those changes?
So the first facilities, as I understand, before my time, well before my time, the first tanks that were on campus to actually raise fish, hold fish for trials, were actually in our administration building into the basement. And I think you mentioned earlier, you remember those being there as well. Yeah. Then as projects grew, and projects, well, not only individual projects, but the base of projects grew, the aquaculture department just constantly expand and expand. Today we are actually located in 7 buildings on campus. We have 20 plus biosecure rooms, and these rooms would be anything from a space the size of this wet lab that we're sitting in to entire Quonset huts that we would consider a room because it's one big open space. And so from a biosecurity point of view, it's difficult to sort of divide it up internally without affecting what's going on with individual projects. So in fact, we even have one building here on campus that's called the workshop. And it used to be the whole dive room in the front and the workshop for the maintenance staff. And as aquaculture constantly expands, we constantly encroach and take space. And so we still keep it called the workshop, but right now there's all fish in there and different projects.
So what do you mean by biosecurity?
So in most spaces that we go in and out of, we like to manage as best as we can any transfer of pathogens. So we're looking at bacteria, viruses that might be in one stock of fish. It could be one species of fish that could transfer to another, or different year classes, as an example, in our broodstock program. And so we want to be able to manage the movement, not only of the people and the equipment, but also the pathogens that can actually travel along with the equipment of the people. And so typically when the project is going on in a room, you'll have a foot bath that you have to step through. Right. It has a disinfectant very similar to what you would use in the hospital setting. And then all of our equipment that's used in an identified space would either stay in the room, or when it's used in the room with a stock of fish, before it comes out to go into another stock of fish, it's got to be disinfected in transit, basically. And so that's how we just manage projects and manage risk. It's about managing risk, really.
Really, yeah.
Right. You talk about Huntsman being a collaborative institution. There's been, university membership, ASF, DFO. Can you talk about that in terms of the work that's being done here?
So Huntsman, as you said, we talked about it's a collaborative organization just with other universities. We have several universities that are members of the Huntsman. In large part, that comes to Huntsman through the education type programs, where a university will come for a 2-week field course on marine sciences from Ontario. But in addition to that, the universities have access to our labs. So you can see PhD, master's level students doing their theses, dissertation, research here on campus.
Using the facilities.
Using the facilities, using our expertise as well, if need be. So we do have PhDs on our staff, on our payroll, and they could also be on committees for students at UNB, as an example, back and forth.
Examining committees, is that right?
Examining committees, yeah, going through. Within the Huntsman itself, we talk about these departments on the campus itself, and you mentioned the 4. But none of us actually happen and work in a silo. There's a lot of cross-pollination between the departments. Right. And so as an example, the Aquaculture department might be doing some field trials on CKH sites or environmental monitoring. To do that, we'll pull in the research vessels, right, because we need access to the sites. Yeah. The Huntsman also, of course, you've already visited the ARC, the Atlantic Reference Center. So if we have any kind of field monitoring of benthic monitoring.
Benthic meaning the bottom?
Bottom, checking changes out from some kind of treatment in the aquaculture industry. Then of course we wouldn't have our own staff. We have the Atlantic Reference Center and their expertise and their facilities. Right. We also, of course, collaborate heavily with the aquarium, and that gets back into our friends behind us. So these are the seahorses from the aquarium.
Okay, so why are they here?
Well, during the winter months, we maintain them as pets. Okay. And so the Aquaculture department has a lot of expertise to bring to bear for the aquarium and husbandry, right, meaning keeping the fish alive, checking water samples, feeding the animals. And so in the wintertime, we actually house, and we actually are responsible for feeding the seals as well, as an example. Right. And then broadly collaborating, we have a lot of we do a lot of work with UNB as sort of the primary university at the Huntsman. We also collaborate heavily with other, we don't do any research in the Aquaculture department for basic science purposes. So we're not a curiosity-driven institution.
All applied.
It's all applied, and it's all contract-based. So either getting funding directly from contracts from companies that write us a check to answer a question, or through programs such as our broodstock program, whereby a company will come in with a co-funding from ACOA AIF, Atlantic Innovation Fund, or the New Brunswick Innovation Foundation, in that specific case with the companies involved. So collaboration, the Huntsman also has a broad spectrum, I guess, of how we approach research. So you might have a company that would want to use space here and have nothing to do with our technical capacity. You just need wet lab space. Sort of an incubator for wet labs.
So this being a place like no other then in the region?
They're very limited for sure. Most institutions you can't rent a room and get access to a door to a building and a lab. In most cases you have to use faculty or staff or students that are involved directly with you. In our case you can actually come and rent a facility. There's several rooms on the campus where companies are here. And they pay a rental fee and they have their own staff, they do their own thing. We always maintain things from a chemical health and safety perspective, but other than that, they're doing their own data collection, etc. Then the other side of the range is actually coming here with a big project where Huntsman is actively involved in devising the projects, collecting the data, doing the analysis. All research that actually occurs on campus must go through an animal care committee. So no matter what you're doing, we do have oversight on animal care and creating the animal use protocols. But otherwise, you could be entirely proprietary, all the way through to getting us to publish results and getting the word out there, I guess, about products that are created.
So over the years, the types of companies or projects that have been done here independent of Huntsman, are you able to talk about any of those historically? I mean, maybe what's happening here right now might not be able to talk about, but things that have happened in the past, give people a sense of the breadth of stuff that's gone on.
Sure, yeah. So over the years, salmon aquaculture is the big one that we always see and hear about. But over the long term, we've had many companies come through that have done everything from alternate species, what we call alternate species, meaning like a cod, something that's not dominated by salmon. Could be the same salmon farming companies, but it's a different species.
So they're just looking to diversify in some way, shape, or form, yeah.
Right. We also, on staff, we actually do have a genetics and breeding specialist, being Amber, who you're going to talk to later.
Right.
So her involvement has been through projects here, but also working with companies on their own broodstock programs, doing statistical analysis, setting up their breeding designs. It doesn't have to be on campus, but she can have her expertise that is fairly mobile, I guess, right, through the internet, etc. We also do quite a bit of research today. Research on sea lice actually began at the Huntsman in 1988. And it's still an issue today in the industry, but it's one of these issues that sort of goes high and low based on the impact and what other issues the industry are facing. Right. And so we do quite a bit of research here. The regulatory framework, I guess, of getting a new compound therapeutin approved in Canada is pretty burdensome for the companies. So we do a lot of work with the pharmaceutical industry that's trying to collect the regulatory data that's required for submission to be allowed to use a compound. And this can range from anything from putting a few sea lice in a petri dish on a bench top and exposing them at different concentrations just to see the impact on the sea lice. Right. And then the next step in responsible way of developing the data set is to then perhaps expose the fish to the compound with no sea lice, just to see if it's palatable. Fish, if it's not palatable, fish will take food in and spit it back out. And so you don't want that to happen if it's an in-feed treatment. And then the next step would be to introduce sea lice to the fish with the compound and test the efficacy or the ability of the compound to actually remove the sea lice. And then a new branch that we're actually getting into is sort of what we call non-target species. Another technical word would be ecotoxicology. And so we're looking at the toxicity of the compound to non-target species. Of course, around here, the important non-target species is the American lobster. And so we would actually do projects. In the future, we have projects that are collaborative projects again that are lined up that would involve force-feeding lobsters with the compounds to see what the effects would be. Because it's no point going out there with a compound that would do damage to other sectors that are using a common space. Also on campus, there's nutrition research. The list goes on and on of capacity.
I remember, again, back when I was here, there was a fair amount of work done around sort of the infrastructure components, technology, hardware, sea cages, evaluating new designs in sea cages, or from things that would possibly be able to be located well offshore, to those that had unique designs so that nets could be cleaned easier. Is there any of that goes on? Development of new sort of hardware, tanks or pumps or.
We don't do a lot of that today, hard technology related stuff. Of course, we're always open for business to do that. Our staff is capable of doing that type of research. We have access to marine aquaculture sites. Some of our technology has moved down the road more to the lab-based stuff, so developing technologies would eventually be applicable to the marine sites, but we're doing it sort of at a lab scale first. And then eventually we would hope to be involved in the project to take that to the next level in the field. Another technology we do have is related to cryopreservation. So there's a company actually on campus today that is using Huntsman space as an incubator for their work. And what they specialize in is cryopreservation of the actual sperm or milt.
So when you say
fish.
cryopreservation, what exactly do you mean?
So in all industries that have broodstock programs, you're looking at cattle, poultry, you've heard the phrase super bulls. And super bulls might be a cow that came out of the 50s that's got great genetics. And so what they do is cryopreserve. They put the milt or sperm in liquid nitrogen, and it's flash frozen.
Frozen, okay.
Yeah, much the same as sperm banks for humans.
Okay.
But in this case, it's related to fish. And in that case, the company is in North America, is located in British Columbia, and they use our space, and our technicians are trained to actually operate the dewars where the fish milt is preserved in liquid nitrogen. So that's highly technologically advanced, I think, but it's just not hardware like you're talking about out in sea cages, etc. Yeah.
So this is among one of the current programs, the projects going on. What are some of the other things currently happening here that you might want to talk about, or that we could take a look at?
Sure. So the primary project we have on campus today that takes up a lot of our manpower and our capacity, facilities-wise and expertise, is actually an Atlantic salmon broodstock program. I won't go into any details of that, so I think we're planning to talk with Amber after. There's also several spaces on campus that are rented directly to companies, so it's everything from the cryopreservation that I mentioned, to nutrition research, to clean sea lice technology development, using a cleaner fish. A company is involved in that in one of our buildings. And we also have another company that recently have actually rented some space that's related to aquatic health, broadly say at the moment. So those are the outside companies that don't really involve much of the Huntsman. In addition to the broodstock program, we always have small projects ongoing, primarily related to sea lice, various treatments. Again, it's all about the data collection for regulatory approval. In some cases, there's some bioassays, we'll call it, as exposure of the sea lice in a petri dish, where there's always ongoing monitoring to ensure that there's no resistance occurring in the sea lice itself, which is pretty important. I mean, you think about the flu vaccine in humans. It's an ongoing basis to, if you use the same flu vaccine from 10 years ago, it probably wouldn't be very effective today. So that's always an ongoing aspect of our research as well. And on campus as well, there's a couple of projects as well that's related to UNB and graduate student work. So a doctoral student is doing some research here on cod and the infection of loma. Loma is another parasite that affects cod. So it's a pretty dynamic environment.
Yeah.
We have 6 technicians. We have a supervisor independently over here managing, and it's a big orchestra. You can think about the dance that's involved. Think about the biosecurity component of that. We rotate technicians because we don't want technicians to get bored doing the same task day after day. So on a weekly basis, we try to rotate them. But in the rotation, there's always got to be a lot of communication. As you're walking through, you'll see whiteboards up where there's a lot of data about what's going on in specific tanks and systems. Yeah, it's a big dance.
So those technicians have to be well versed in a number of things, and they all have to know what everybody else is doing and have experience in that too.
So our technicians are all highly trained.
Right.
We have Amber is a PhD in genetics and breeding programs from North Carolina State University. Susan Odkinson is our supervisor over here in the aquaculture department, and she was actually an assistant manager. She's from here locally, but she was an assistant manager of a facility in Alaska producing 120 million smolt a year for stock enhancement. So wanted to move back home and gladly took her.
Yeah.
So it's when you consider that capacity, human capacity, it's pretty incredible. And then the technicians could be doing everything from just feeding fish to monitoring systems, basic engineering, water quality sampling, so it's chemistry related, fish health, biosecurity, so it's and everyone's got to get along because you got thousands, tens of thousands of animals. You got to make sure things are done properly, basically. Very protocol driven. So everything is written in a protocol that's approved through an animal care committee, and things have to be done. So some of the things we're doing, not day to day, but certainly in a program, could be something as high tech as pit tagging individual fish, where we knock the fish out, measure them, do a little incision in the fish, put a small transmitter pit tag in the fish so we know them all individually, and they're all knocked out and anesthetized, and then we put them back into the system. So now we can track them in any project through multiple, basically sampling periods. Yeah. And any one of our technicians can be drawn on to do that. Sea lice counts, whatever, ultrasounding fish, whatever you want to name, and crack plumbers. So a lot of waterworks here, so there's a lot of things that have to be changed, pumps-wise. So some of our buildings are actually, when you think about the plumbing of here, we actually we share collaboratively, we share a water supply with DFO. Right. DFO is also the home of our vessel, berthage for our vessel. But we share a water supply system with DFO. And we pump up the hill roughly around 740 US gallons per minute. On the campus today, we require water through our projects of about 1,380 US gallons per minute. And we do that because we recirculate so much water. Right. To recirculate systems, you'll see some of those systems as you walk around. It takes a lot of technical capacity. Because any one thing, too high of ammonia, bad pH, anything can throw the entire system off and all the fish will die.
Yeah, wow. It really is quite a dance, as you said. Yeah. Well, I'd be interested in hearing a little bit more about this Atlantic salmon broodstock program that Amber Garber's involved in. So why don't we break from here, and I'll go and find Amber and talk with her a little bit about that.
Sounds great.
Chris, thanks very much.
Thank you.
Cheers. All right, here we are back at the Huntsman with Amber Garber, research scientist here in the aquaculture program. We're in one of their biosecure rooms. We're in and amongst 36 tanks. And we're going to talk a little bit here about the Atlantic salmon broodstock program. Is that right?
Correct.
That Amber is heading up and will be running when? When, we don't actually have anything but water in the tanks right now.
These tanks are being cleaned and disinfected at the moment, and soon there will be eggs in each one of the tanks. So in each one of the individual tanks we'll have a single family, and then when the fish get to around a 10-gram average, we will put pit tags, passive integrated transponder tags. They're about the size of a grain of rice. Into
passive integrated transponder.
Transponder tags.
Okay. So they're
They are RFID tags like you would put in your dog or cat, similar to...
Maybe you'd put in your dog or cat. But
And so when we pass a pit tag reader over one of these tags, it energizes and it gives us a number, and we can track the individual fish with that number. So we will have some fish designated for the breeding nucleus, where we'll have our selected fish.
So, transponder. So this is implanted in the fish, and it generates, there's a number associated with it.
There's a number associated with it.
And does the fish have to be passed over any kind of sensor, or does this transmit a signal?
We actually would have an individual fish. So if you were spawning, for example, right, you would actually have a fish out of a tank, and so you would pass it over the fish. Or if the fish is going into a disease challenge or a sea lice challenge, right, then we would actually do measurements before the challenge, right, and we would scan those fish for the measurements, any mortalities we have. Or if we, with a sea lice challenge, we do sea lice counts on the fish, so we know which individuals are resistant or susceptible to sea lice. Okay. And so at that time we would scan the fish and then count the sea lice and record that data. Right. Okay. And so all of this data then goes into a database program that we have, and And what I can do is link it all together and spit it back out and put it into another program to estimate breeding values and develop an index, a total merit index, where we can try to select faster growing fish that have good survival, that are disease resistant, and that are resistant to sea lice as well.
Okay. And from those, then you have you create a sort of a brood stock that has, well, you know, high merit. They're
correct.
Yeah,
they're elite brood stock that have been naturally selected. So we use the genetics that are inherently in the fish, the genetic variability we have in our stock. So
each of these tanks will have fish in them.
correct.
Plus in another.
And we can go look at some other tanks with other year classes. So this would be the most recent year class, the 2013 fish. We also have 2012, 2011, and 2010 fish as well in the broodstock program.
Okay, so this program has been going on for
Since 2010.
Okay, and is it projected to continue for
Forever.
forever and ever? Amen. And what sorts of results have you been getting? I mean, have you those 2010 fish?
So the 2010 fish, we have smoltification data. So we have data from the fish going from freshwater to salt water. So there's some family variation there. We're collecting data on early maturation. We've collected data on BKD, bacterial kidney disease. We did a disease challenge down at the DFO.
So what would be involved in that?
So in that challenge, each individual fish was injected with BKD. And then we just track the fish and we look at mortality over time. And we can use that data then to, again, see if a particular family is resistant or susceptible to, and individuals vary, but you'll find, say when the individuals initially start becoming moribund in the BKD challenge, you can see that a lot of them are from similar families. Okay. So we do see a big range in the disease, in the resistance and susceptibility for diseases. We also see a big range in disease and resistance and susceptibility for sea lice as well. Okay. So there are fish that are more resistant to sea lice, and there are families that are more resistant to sea lice.
So is that something that you expected to find?
We did expect it. We do have, I think the salmon are pretty genetically variable, and so when you have genetic variability, you do see variability in traits. But sometimes you may not see a big variation between families because you see a big variation between individuals within families. So sometimes it gets a little muddy in the analysis, but we did see some large variations between families. So we hope that we will be able to develop an index where we can grow fish faster that are resistant to sea lice and BKD, and also that survive well and that type of thing. So better than they do now. So this is an improvement. But we're using, like I said, the inherent genetic variability of the fish themselves.
So thanks for joining us once again for this episode of Submersed in Science. We've been here at the Huntsman Marine Science Center in the Aquaculture Department talking with Amber Garber and Chris Bridger. It's been a great day. So we hope to see you again when we're back again with another episode.